Okay, so Maya, you did a problem yesterday, and so the first thing is, can you tell me what, I'm going to hold this up just for a second so that I remember which problem we were talking about. Okay, can you talk me through that problem again?
Well, I wanted to split, I was wondering if we had 2,300 people at our house, how many people would be in that house if you could split it up evenly, and how many people would be in the yard?
So wait, so why 2,300 people in our house?
Well, there are 100 children, 200 moms and dads, 1,700 aunts and uncles and cousins, and then 100 grandparents.
Where did this story come from, honey?
Well, me and Daphne were talking about it, what it would be like to have that many people in the house, and then I started thinking about it.
Okay, so why did you decide to put them evenly on the 3 floors?
Well, I wondered if they had all came over to stay, how many people would be on each room, and not just have the 2,300 people on the first floor, the third floor, the second floor, have them spread out evenly.
Okay, and
so
then
now one floor would be crammed and the other two would have 2 people in them.
okay, we're going to be crammed even anyway with 2,300 people at our house. Right?
I know, but
so
this is the least crammed it could be.
Okay, I get that. So how did you start, and you and I did this a little bit together. I did the writing and you did the thinking. I'm going to put the dogs up here. How did you decide how many people to go on each floor?
Well, I started doing it with the hundreds, then went to the, I started with putting 700 on each floor.
Why'd you pick 700?
Well, I kind of didn't want to do it by one, so I thought you couldn't do 1,000 on each floor because we only have 2,000 and there are 3 floors. So then I tried 900 and that didn't work either. And then I tried 800 and that didn't work either. So then I tried 700 and it worked. So then I got rid of 2,100 and then I did 25 on each floor. So, and I got rid of 75 and then I got rid of another 75. And then I got rid of 30.
By putting how many on each floor?
10 on each floor, and then I did 6s.
So you had 20 left after doing 10 on each floor, right?
And so I did 6s, but there were only 2 people left, so we had to put them in the yard because we couldn't have them spread out evenly. On 3 floors, we couldn't have 2 people spread out evenly.
Awesome. Okay, so what I am really interested in is everything you just said, but also something you said last night when we were talking about those 2 people. So you said
we can't cut them up because if we cut them up in half, we would be able to do a half on each floor, but still we would have a half of a person left. So we couldn't do that.
If we were going to cut them up, how could we do it fairly?
How
many pieces should we cut each one into?
Well, we can't do it evenly and make it so there's not anything left over because, well, if we cut both of them in half, that will give enough to go on these 3 floors, but there would still have a person left, so we can't do that. So, and we can't leave one person whole, but cut one person in half and have 3 pieces, because that wouldn't be even.
Is half the only way to cut them?
No, you could do it into thirds and fourths, but that would be even more, and more left over, so we can't do that.
What happens if you cut them into thirds?
Well, then you would have 6 pieces. And, well, you could do it like that, but we can't cut the person in half and have them still be there.
Okay, so if we cut them in thirds, we're not being very nice to our family? Is that what you said? Okay. So when you were thinking about these 2 people last night, you said to me, 2 divided by 3 is between 1 and 0. Do you remember what you were thinking when you said that?
Well, it can't be 0, because
Yeah, I'm here to help you, honey. This isn't a test. This is me trying to understand what you were thinking, because you were onto something, but I'm not sure how much of what you said you understand. So here's what I think you were saying was 2 divided by 3 is between 0 and 1. And you said 1 would be if we took care of all the floors, if there was a person on all the floors. And 0 would be nobody. But then you said something about being between 0 and 1. You don't remember what you were thinking?
It has to be between 0 and 1, because if it isn't, then it can't be that for those reasons, so it has to be in between 0 and 1.
What has to be between 0 and 1?
The people.
Okay, when we think about 2 divided by 3, what was the 2? What did the 2 stand for?
The 2 people.
Okay, and what did the 3 stand for?
The 3 floors.
The 3 floors. So 2 people divided by 3 floors. If the answer were 1, what number of people would you have to have the answer be 1?
2,301 instead of 2,300.
Okay, I think I see what you're saying. Can we make a new house? I'm gonna draw a new house, and we're gonna have 3 floors. And I want to know how many people you would have to end up with 1 person on each floor.
What do you mean?
If you had just a few people here and you wanted to have 1 person on the 3rd floor, 1 person on the 2nd floor, and 1 person on the 1st floor, how many people do you need?
3.
Okay, can you draw them in there? 1, 2, 3. Okay, so I'm going to just tip this down so I can see what you wrote. Okay, so we have 3 people divided among 3 floors. And how many people are on each floor?
1.
1. So that when you were talking about in between 0 and 1, you might have been thinking it had to be less than 1 person per floor because we didn't have enough people to put 1 person on each floor.
Yeah, but if it was 0, it would be nothing because 0 is nothing.
So that would be 0 people divided by 3 floors. We still have 3 floors, right?
Mm-hmm.
Would be 0. Okay.
This is what it would be like to have 1. This is what it would be like to have 0.
So then where is
it
2?
It has to be in between.
What has to be in between?
It has to be, the numbers have to be in between 1 and 2. It can't be like it can't be. It can't be like this. It has to be in between, because if it was 1, it wouldn't be even, and if it was 0, it would be nothing. Those people wouldn't be there.
Are these balance scales?
Mm-hmm.
Tell me what the balance scales have to do with it.
Well, it was showing that if it was about something like half or a little or like thirds or something, then it would work, but it wouldn't work to have 1 on the floors or 0 on the floors, because it can't be 0, because it wouldn't be anybody on any floors. If it were 1, it would take care of 2 floors, but not all 3.
Okay. So this is why you're saying it has to be between 0 and 1. 2 divided by 3 has to be between 0 and 1. What does that mean to be between 0 and 1? I bet a bunch of kids in your class would say, what do you mean between 0 and 1? Like, what is between 0 and 1?
Like 1/4, half, 3/4 of 0.
What kinds of numbers are those? Do you know? The word is fractions. Have you ever heard that one? Okay. So you think that those numbers, those are the kinds of numbers that are between 0 and 1. I have another question. Are those kinds of numbers only between 0 and 1, or are they between other numbers too?
They're between other numbers. They're anything between any number.
Between any whole number?
Like, it could be 5 and 1/4, 5 and 2/4, 5 and 3/4, 6. There's a space in between.
So 5 and 1/4 is in between 5 and 6?
Because it's kind of like time.
How's it like time?
Well, like the clock, it's in between the 6, the 7, and the 8. So just like it's in between the 5 and the 6, like that. The clock, it's a half hour, but also the 15 minutes, the 5 minutes, the 10 minutes, the 15 minutes, the 20 minutes, the 25 minutes, the 30 minutes, the 35 minutes, the 40 minutes, the 45 minutes, the 50 minutes, the 55 minutes, and then there's the hour, but it's not just 1 o'clock. Wait an hour, 2 o'clock. It's 1 o'clock, 1:01, 1:02, 1:03, 1:04, 1:05. 106, 107,
Okay.
108.
You're not going to do the whole hour.
It's like that.
It's like that. So you're thinking of the minutes. The minutes are parts of hours that are you're thinking of the minutes as what come in between the whole hours.
Mm-hmm.
So like 5 o'clock is the whole hour, and then 5:15 is somewhere between 5 o'clock and 6 o'clock, right? And so you think, when you're thinking about numbers that aren't timed, that there are also numbers like that in between the numbers 5 and 6, or the numbers between any numbers. So if we're thinking about our people in the house, what would be a number that would turn out to be between 1 and 2? Does that make sense? That's kind of a hard question to understand.
Kind of.
So if we had 3 people, we ended up with 1 person on each floor, right? if we had 2 people on each floor, how many people do we have?
We would have 6. It's doubling.
Ooh, it's doubling.
If we had another person on each floor. We would double the number.
Okay.
1, 2 times.
If we had another person on each floor, would we be doubling again?
No, the first time it's doubling. Then it's counting by 3s.
Okay.
Or 2s, or how many floors there are in a house.
Okay. Can you make a little chart of that? So here, let me make a little chart because I think that's interesting. So if we have 0 people, 1 people on each floor, you said 3, then what'll be the next number? 6. And then what's the next number?
9.
9. So
12.
12. Okay, so what is my question? What am I trying to ask you? I'm not sure. I get you know what, forget the chart. My question is, what happens between 3 and 6? What if we have 5 people?
Well, if we had 5 people, then it wouldn't fill all of the 3 floors unless we cut some of the people in half or something.
So if we had 5 people, how many would be on each floor and how many would be in the yard?
2 people would be in the yard, but we want to split it up as evenly as we can, so we wouldn't make all of them be in the yard. We would just make the 2 that we can't use be in the yard. The 2 that we can't use in the house be in the yard.
How many people would be on each floor if we had 5 people all together?
There would be 1 on each floor and then 2 in the yard.
1 on each floor and 2 in the yard. So then my question is, where is that number? If we were going to put that number on the number line. Well, so we ended up with, you remember with 2 people it was between 0 and 1. So here's 1, here's 2, here's 3. So when we had 2 people, you said it was between 0 and 1. When we have 5 people, where is it, do you think?
Between 3 and 4?
Do you know what I think is really hard? It's hard to keep track of what this number means.
Which number?
The 0 or the 1 or the 2. So the way I'm thinking about it is we had 3 people divided by, I'm just going to use the words, by 3 floors, right? And that equaled 1 what?
What do you mean?
When we had 3 people, how many people were on each floor?
1.
Okay, so the 1 stands for what?
How many people were on each floor?
One person on each floor. So I think these are the things we're thinking about. We're thinking about the number of people, and we're thinking about the number of floors, and we're thinking about the number of people
on each floor.
On each floor, right? So that's where it gets really confusing. So if this number is 5, if we have 5 people, divided by, do the number of floors stay the same or change?
Stay the same, because if they change, the house would either be bigger or smaller. It wouldn't be the same house.
Okay, we're not moving for this math problem. Okay, so if we had 5 people and we were dividing them up on 3 floors, then...
Well, we could count the basement.
Those would be the people who didn't get treated very nicely at the party.
Mm-hmm. Well, we couldn't cram 766 people on each floor. There would be in there would like be 500 in the living room. Every room would be full, and there would still be 100 or 200 people left. Everybody would be like, I can't. It wouldn't be very fun either.
How many people are in our family?
4.
4, and we have these 3 floors. So if we were going to do this problem, just the 4 of us.
Someone would have to be in the yard.
Someone would have to be
Or they would be in the basement.
Okay. Maybe I'll garden, and then you can each be on one floor.
No.
No? Who's going to have to go in the yard?
I'm going to go in the basement.
You're changing the conditions of the problem, aren't you?
I know, we're only going to use the basement for something like that.
Okay, to make it work out so that no one has to be out in the yard.
Yeah, so no one has to be out in the cold winter.
So my last question is about Maggie's house, because you said yesterday, I wonder how this problem would go at Maggie's house. Because what's different at Maggie's house?
It has 2 floors.
It has 2 floors, so it worked out. How did it work out?
There would be 1,150 people on each floor and no one in the yard.
Okay. So the same number of people, it worked out evenly at Maggie's house, but not at our house?
Because it depends how many floors there are.
Yeah.
If someone lived in an apartment building with
Whoa.
like 8 or 9 floors. There's 9 floors. If it was like that, it would be different. But if someone lived in a little cottage with only 2 floors, it would be different.
And how many people are we going to spread through this apartment building?
The same number.
The same number. Okay. Here's my question before you do any figuring out. How many people do we have? 2,300? Are there going to be more people on each floor?
Less, because there are more floors, so it will be less about, because there won't be the people will be more spread out.
Because we're not changing the number of people, right?
We're just changing the number of floors.
So you're saying if we divide them onto more floors, into more groups, each floor or each group would have
Less people.
Okay, let's see. That's your prediction. Let's see. So you want to do it? How many floors do you have? 1, 2, 3, 4,
9.
5, 6, 7, 8. Is that a floor too?
Yeah.
9. Okay. 2,300 people, 9 floors. You picked a tricky number, my dear. What number did you choose to start with?
100.
How come?
Because I knew that out of 2,300 divided by 9, we would have at least 100.
Okay, so it's a good chunk to start with. I wonder if it's going to work out even, or if someone's going to have to be in the yard again.
So, much does that leave us?
I don't know. How are you going to figure it out?
It will be 1,400.
How'd you figure that out?
Well, I started with these three, and so I knew 369, so I took 300 off of the 900. That left me 600, and I know 6 plus 4 is 10 in the fact family, so it ended up with 1,400.
So you broke 900 into a 300 and a 600? So you said 2,300 minus 300 is 2,000? And then 2,000 minus... What was left?
My 600.
Left how much?
1,400.
Okay.
And now, so that left us 1,400. Let's do another 100.
Okay. You know you have enough to do another 100?
Yep, because a 1,000 is 1,000, and there's only 900, so we would still have 500 left.
Okay.
So now,
it's a good idea to keep track like you're doing. So that if you lose your train of thought, you can come back up here and figure out where you are, right?
let's do 50 next.
Okay. Why'd you pick 50?
Well, it can't be another 100 because we would have 4 rooms with only 200. So 50 is half of that, so we would have enough. And then so
How did you know that was 450 altogether?
100, 200, 300, 450.
Great.
And that left us
So what do you have left to deal out? How many people?
Wait, let's do 5 next.
Okay, so you have 50 people left?
Because we can't do 10, because that would only do, there would be 4 left. So 10, 20, 30, 40, 45. I have 5 left.
You have 5 people left.
5 people will go out of the yard.
5 people in the yard. They don't get to go in the house, in the building.
Or maybe they're out doing an errand or something.
Okay.
So we don't... I'm breaking it up to show how we did it.
Okay. And can you make sure to record your last fives?
What do you mean?
Well, you dealt out 5 people to each floor at the end there, but didn't write down that step. So up here you still have 50 people, right?
And then minus...
So how many people are on each floor?
255.
255. That's a lot less crowded than our house was, wasn't it?
It's instead of 1,150. Instead of 766, it's 255.
And how many was it at Maggie's house when it was only 2
Maggie's
floors?
house was 1,150.
Wow. How many would it be if there was only 1 floor in the house? How many on that floor?
2,300.
Wow.
People
What if there were 2,300 floors in the building?
one person on each floor. People would be like, I wish I had some company. That would be a lot of floors. It would take like 2 or 3 years to make that building.
You think so? I don't even know if you can have a building with that many floors. I saw a really neat thing that somebody did online about that. We should look that up. About how tall a building would have to be. I don't know. Maybe it's possible. Let's look into that. We can look into that if we want. Do you have more questions after doing this? What are you thinking about now?
Is there a pattern?
What pattern? Where would you look for a pattern?
If it's an, I think I'm starting to notice a pattern. If it's an odd number of floors, then people are outside. Because when it was 9, 5 people were outside. When it was 3, 2 people were outside. But when it was 6, 0 people were outside. And when it was 2 floors, 0 people were outside, so maybe there's a pattern.
Maybe there is. What would you do to figure out if that will always be true?
Keep doing it.
For what would be your next building? What would you think about? So we've done 1 floor, 2 floors, 3 floors.
4 floors.
And 9 floors, but you wanted to test with odd numbers, right?
Odd and even.
Odd and even. So
So
you want to know if all even numbers, would it work out evenly? And for all odd numbers, does it work out unevenly? Is that right? So
yes.
You want to do 4 floors and next to test the evens, and what would you do to test the odds?
Do 5 floors, keep going up until I get to 10, and then I could start figuring it out.
Huh. Do you want to do that now, or you want to take a break and do that another time?
Now!
Okay. I have more paper. So you want to do 4 floors?
Can you draw the house?
You drew a great house. Your problem, Maya, your representation. This is a great problem, by the way, kiddo. You have designed a great problem. Because it's interesting, and it's interesting to you. And it has good math in it. Okay, so let me make sure I understand your conjecture. So if it works out...
1, 2, 3, 4.
Okay, so if all even number floored houses work out evenly, you expect no one will be in the yard, right?
Yep.
Okay.
So
You know I'm going to ask you to tell me why you picked 300 as your first chunk.
well, I didn't want to start with 100, and neither did I with 200, and so I picked 300 because I knew it would be enough, and then I did 300, 600, 900, 1200.
Okay.
Not 3,300. And then 100. I chose 100 because I knew it would be enough, and I didn't want to take the time figuring it out.
Okay.
And then, wait, so equal.
How'd you do that? 1,100 minus 400.
Well, 1,001. Well, I started with 1,100. I took the 100 away. I know 10 minus 3 equals 7, so I knew 1,000 minus 300 must equal 700.
So now what are you going to do?
I have to do 100. I can't do 200, 200, 400, 600, 800. I only have 700 left. '50s.
What do you have left to work with? You have 300 left to work with?
$25.
How'd you pick 25?
Well, I knew it couldn't be another 100 because we only had 300 left.
Mm-hmm.
I mean,
Wait, how much did you have left? You have 100 left.
So I started with 25. 25 plus 25 equals 50. 50, and then there's another 50, so that equals 100.
Anyone in the yard?
Nope.
So how's your conjecture doing?
That is 575.
And nobody out in the cold.
$575.
Read me that number that you wrote down there. You don't have to cross it out. That's really good thinking, honey, and it's very normal for kids to write like that. Okay, so how do you want to write 575? What made you change your mind?
Because 50075 doesn't exactly make as much sense as 575.
Okay, so this number 50075 makes sense to me. It's just not 575 because those zeros.
What is it?
This number would be 50,075. That would be an even more crowded house than our house.
Very, very crowded.
So now how's your conjecture? What did you think?
It kept going.
It kept going. How come?
Because there's no one left in the yard and it's an even number.
Okay, I'm going to let you do one more tonight and then we have to go to bed. So you wanted to do 5?
5.
To test, and you thought if it's odd, there always is going to be someone in the yard.
Yep. So 1, 2, 3, 4. So. So. 200.
Okay. Is that 5 or 4? Yeah, that bottom 4 is confusing. So how much is that?
700.
What?
Wait, not 700. 1,000.
And how much is 1,000?
1,000.
Okay. Because there are 10 hundreds and 1,000?
Equaled.
That took a lot off it already.
$100. So equals 800.
So tell me all the steps there. So you did 100 on each floor, and how many people is that altogether?
That is 500.
And then you subtracted 500.
I started with 3 and then I subtracted 200 more.
Okay. So 1,300 minus 300 was 1,000. Minus 200 more is 800.
Now I'm going to do another 100.
Okay. Love how you're using the landmark numbers there.
What do you mean?
When you subtract and you get yourself to 1,000, right? Like from 1,300, you took off 300 to get to 1,000, and then 200 to get to 800. 1,000 is such a great number to use, right?
Just like 10, like 7 isn't such a friendly number. 10's easier to work with.
Yeah, 1,000 is the same for me.
Mm-hmm. So equal 300. I can't do 100 because there would be 200 left.
You doing 50s?
Because I couldn't do 150 is the next kind of easy number to work with.
And you know you have enough to give 50 to each floor?
So
What?
it will work out evenly.
How did you figure that out? What did you skipped ahead a few steps in your mind, right? So what did you think?
That's 250.
Right. Which leaves you how many people?
Which leaves you 50, 10, 20, 30, 40, 50.
Okay, so now what are you thinking? Is 5 an odd number or an even number?
Odd.
Odd, but no one's in the yard.
Maybe for some numbers it works like that, and some numbers it doesn't.
Yes. I wonder what the reason is why it works for some numbers and not others.
Maybe if we do 700 we can find out.
700 different buildings?
No. 7 floors.
Maybe tomorrow.
I know, because 5's a friendly number, so maybe but it's been with all the other numbers, so maybe it's just friendly numbers like that.
Here's a question. You know how sometimes you count by 5s? 5, 10, 15, 20, 25, 30, 35, 40, right? Do you think you would say the number 2,300 if you were skip counting by 5s? Why?
Well, you say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 40, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. You say all the hundreds.
Yeah.
And if it was 2,301, you wouldn't say it because you say some things, but you say all the ones that end in 100. Even though it's an odd number,
What's an odd number?
2,300. Wait. No, it's not.
How do you know if it's an odd number or not?
The n number.
What does the n number tell you?
If the n number's odd, it's an odd number.
How do you know that to be true?
Well, I've heard people saying that, but also I've counted with numbers like 117 and it's odd, and the last number's odd.
How do you know it's odd if you're counting with it? What are you really trying to do?
I was counting by twos and I didn't say it. When I stopped at 120 and I thought back and I was like, I didn't say 117, so it's an odd number. But then when I tried 114, I said it, and the last number's even, and I did it like that, and it worked for every single one.
So you tested that out a lot. Does that have anything to do with Maggie's house? The house with the 2 floors?
Maybe.
If I gave you any number and it were even, would there be people in the yard at Maggie's house?
I'm not sure.
Maybe that's the next thing we should play around with. Because I remember when you first learned about odds and evens in kindergarten with Lindsay, what did you do?
If it's an odd number and you give it to me, there would be someone in the yard. Like 2,301. There would be someone in the yard because you wouldn't be able to do it. But if you say it when you count by threes,
You're writing all three.
if you say it when you count by threes, then you'll do it because you're doing. No, if you say it when you count by twos, then you'll do it because there's 2 floors.
There's 2 floors.
So if you say it when you count by twos, then it will then it's an even number, and there will probably be no one in the yard.
Okay, so for 16 people, would someone be in the yard?
No.
For 24 people, would someone be in the yard?
No.
Go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I started at that one, then I ended at that one, and I ended at that one.
So, do you remember what I'm trying to get you to remember with Lindsay?
22, 23, 24.
Do you remember that at all? She had something to do with towers. You had towers of cubes. And there was a way that you could figure out if a number was odd or even.
Oh, I remember. It was Miss Kern says there's an odd man out.
There's an odd man out, like someone in the yard, right? So if it's a two-floor house, then there's kind of a fast way to figure out if there are going to be people in the yard or not for any number, if you know about odds and evens. I wonder if thinking about that more will help you decide about rules about odd and even numbers of floors with our 2,300 people in our family. I think we should stop. This has been going on for a long time. I love talking math with you, Leia.
Me too.
What do you think you're going to do tomorrow? You don't have to wait for me. You can do it whenever you want. I just wanted to catch a little on video.
I think I'm going to play around with the odd and even numbers and see, well, if you count by fives, if you say it when you count by fives, it will end up with someone in the yard because 5's kind of a friendly number, so just like 10 and 15 and 20 and 20. Well, not so much some of the numbers when you say, but when you count by 5, but when I get to 10, I might skip ahead and do 15 and 25 and 35 and 45 and things like with those, and see if all of those will end up with no one in the yard. But if one does, I can't think of a pattern right now.
And then for your even numbers, it's worked with every even number so far. So which even number are you going to test next?
Numbers that end in 7.
Are those even numbers?
I mean, numbers that end in 6.
Okay. So yeah, you haven't done 6 yet, have you?
And 8.
I wonder about the number 6. I think 6 would be a really interesting one to do. Because if all even numbers work, then you would expect no one in the yard with 6, right? So maybe 6 would be a good one to do next, too, after you do your multiples of 5.
Mm-hmm.
Thank you, honey. Thanks for thinking it out loud with me. I always learn when we do it together. Okay?
Tomorrow, can we do a little more on video?
You like being videoed?
Mm-hmm.
How come?
I like sharing with people what we do and how we do it.
Yeah. Why do you like doing math together like this?
Well, it kind of makes me happy.
How come?
It just does.
The math part or the together part or both?
Both.
Yeah, for me too. Okay, I'm going to turn this off now and let's get you to bed.
Okay.